Welcome to episode 54, Infrastructure as Code and ARM Templates, where we define what infrastructure as code really means and why it changes everyday cloud work. Infrastructure as code treats environments like software. You describe the desired state, store that description in version control, and let automated tools create or adjust resources to match. This approach replaces manual clicks with predictable, reviewable changes that leave an audit trail. It matters because consistency beats heroics. Repeatable definitions reduce drift and make recovery routine. Imagine needing a copy of production for testing. With code, you can spin it up, test, and tear it down safely. The mindset also improves collaboration because pull requests and code reviews replace hallway conversations. In short, infrastructure as code turns environment building into a disciplined, shareable practice. Azure Resource Manager, often shortened to ARM, is Microsoft's native engine for declarative deployments. An ARM template describes resources and their properties, and the platform converges the real environment to match that description. Declarative means you focus on what rather than how, letting ARM handle order, dependencies, and idempotence. Templates ensure that running the same deployment twice yields the same end state, not duplicates. They also provide granular change tracking through deployment history, making audits straightforward. Consider deploying a storage account and a role assignment together. The engine discovers the correct sequence automatically. Declarative definitions reduce orchestration complexity and free you to concentrate on design. Bicep is a higher-level language that simplifies authoring ARM templates without changing how deployments work. It compiles into standard ARM JSON, so everything the platform understands remains available, only with cleaner syntax. Bicep adds features like simpler parameter handling, better type inference, and module composition that keep files readable as solutions grow. Teams often start in Bicep for clarity, then examine the compiled JSON when troubleshooting edge cases. You still get full fidelity with resource APIs and can mix Bicep modules across projects. Because Bicep is transparent and reversible, it is a safe on-ramp for organizations already invested in ARM. The result is faster authoring, fewer mistakes, and easier code reviews. Every template follows a clear structure that keeps definitions predictable and maintainable. The schema line tells the engine how to interpret the document and what language features are available. Parameters capture values that change across environments, names, sizes, locations, so you do not hardcode them. Variables compute reusable fragments, such as concatenated names or object literals, to avoid repetition. The resources section defines what will exist, while the output section returns useful values for later steps. A thoughtful structure separates configuration from logic and clarifies intent. When teammates read your template, these sections act like landmarks, guiding them through choices, calculations, and results without guesswork. Modules, reuse, and project organization turn scattered templates into a coherent library. A module encapsulates a small solution, perhaps a virtual network or an application gateway, with parameters and outputs that hide internal detail. By composing modules, teams build larger environments from tested building blocks rather than copying and pasting. Good organization mirrors the architecture. Keep foundational modules separate from workload modules, and keep environment-specific files in dedicated folders. Naming conventions, consistent parameter names, and clear README notes make a shared library discoverable. Over time, reuse yields speed and reliability because teams deploy proven patterns instead of inventing new ones under pressure. Reuse is how infrastructure as code scales across many projects. Deployment scopes define where a template applies and how broadly it can act. Azure supports resource group, subscription, management group, and tenant scopes, so you can place controls and resources at the right layer. A resource group scope is ideal for app stacks, while subscription or management group scopes handle shared policies, role assignments, and governance foundations. Choosing scope carefully prevents templates from reaching farther than intended and aligns privileges with least privilege expectations. You can even mix scopes within orchestrations, promoting guardrails centrally while deploying workloads locally. Thinking in scopes keeps architecture and control in balance. Pre-flight checks, such as what if and validate, catch problems before they reach your environment. Validate ensures the template is well-formed and parameters satisfy constraints. What If simulates the deployment and lists exactly which resources will be created, changed, or deleted. This preview builds confidence, supports peer review, and prevents accidental drift or destructive updates. Teams often treat a clean What If output as a gating condition in pull requests. When the plan looks wrong, you adjust the template rather than fixing production later. These checks help transform deployments from nail-biting events into ordinary steps in a routine. Parameter files and secure secrets make templates portable while protecting sensitive data. A parameter file captures environment-specific values, development, testing, production, so the same template can deploy everywhere without edits. Secrets such as passwords or keys should never live in source code. Reference them from a secure store and resolve them at deployment time. Consistent parameter names reduce confusion and simplify automation scripts. With clear separation, you can review templates publicly while restricting access to secret material. This pattern supports compliance and keeps audits simple because evidence shows where sensitive values originate and how they are injected safely. Template specs and versioning approaches bring governance to shared definitions. A template spec stores an approved template version inside Azure so teams can reference it by name and version rather than copying files around. You can pair template specs with semantic versioning in source control, labeling stable releases and tracking changes over time. This creates a registry of blessed building blocks that remain discoverable and consistent. When a new version ships, consumers adopt it deliberately rather than accidentally drifting. Versioned distribution turns one-off files into a reliable platform for many teams and projects. Troubleshooting deployments is easier when you understand how the engine reports errors. Messages usually identify the resource type, the failing property, and the cause, such as a missing dependency or an invalid name. Start by checking deployment history for correlation identifiers and review the compiled ARM that Bicep generated, which can reveal mismatched property names. Narrow issues by deploying a minimal reproduction that isolates the failing resource. When a dependency chain complicates things, add explicit depends on statements temporarily to verify order. Logging outputs and echoing parameter values during validation often surface incorrect assumptions. A calm, methodical approach resolves most template issues quickly. Pipelines integrate ARM and Bicep deployments into a repeatable lifecycle. A typical flow validates, runs What If, requires approval, and then applies the change, all under a service identity with least privilege. Artifacts such as parameter files and compiled JSON are stored with the build for audit. Rollback plans can redeploy the previous version or reapply a baseline template if needed. By embedding deployments in pipelines, you remove reliance on personal machines and avoid silent local changes. The pipeline becomes the trusted path for all environments and the place where policy, testing, and security controls meet. Choosing infrastructure as code over the portal comes down to intent, scale, and risk. The portal is excellent for exploration, quick fixes, or learning service options, but it does not capture a durable record of decisions. Infrastructure as code shines when environments must be rebuilt, peer-reviewed, promoted across stages, and proven to auditors. If you need speed with safety or many hands working in parallel, code wins. A hybrid model can also work. Prototype in the portal, export or translate to Bicep, and then harden the result into a module. What matters is ending with code you can trust tomorrow. Consistent, auditable deployments are the payoff for adopting infrastructure as code with ARM templates and Bicep. Declarative definitions ensure idempotence, modules enable reuse, scopes connect architecture to control, and pre-flight checks prevent surprises. Parameter files and template specs make sharing safe and predictable, while pipelines carry everything forward with approvals and logs. When teams live in this model, environments stop being fragile snowflakes and start behaving like reliable systems. The outcome is confidence, the knowledge that what you deploy today can be redeployed next week, inspected next month, and evolved next year without losing the thread.